You know that in 2012, ordinary people, not scientists, not soldiers, not people in a disaster zone, just completely normal people sitting at home, were writing their wills and saying their final goodbyes to the people they loved most? They were holding their children tightly, hugging their wives and husbands, wiping tears from their faces, genuinely and completely convinced that they would never see them again after that day. And the reason for all of this fear, all of this panic, all of these tearful goodbyes, was a single scientist in Switzerland about to press one button. This was not a Hollywood movie. This was not a science fiction novel. This was not an internet rumor. This happened in real life, on a real day, to real people around the world. So the real question is, were these people completely wrong and overreacting? Or was there actually something worth being afraid of? Stay with me, because I am going to tell you the entire story from the very beginning. Deep beneath the ground, running along the border between Switzerland and France, hidden completely from view, something that had never existed before in human history was quietly waiting. The largest, most expensive, most complex machine ever designed and constructed by human hands in the entire recorded history of civilization on this planet. It is called the Large Hadron Collider, the LHC, a perfectly circular underground tunnel stretching 27 full kilometers in circumference, buried 100 meters beneath the surface of the Earth. Inside this tunnel, the temperature is maintained at minus 271 degrees Celsius, which is actually colder than the empty vacuum of outer space itself, which sits at minus 270. Inside it, subatomic particles smaller than anything you could ever see or imagine are accelerated to 99.9999991% of the speed of light, a number so close to the absolute limit of physics that it barely seems real. At that speed, in just one single second, a particle traveling inside this machine completes 11,245 full laps around the entire 27-kilometer tunnel in 1 second. And then, at precisely the right moment, two beams of these particles are aimed directly at each other and allowed to collide, releasing an amount of concentrated energy that has not existed on Earth since the very first moments after the Big Bang. All of this enormous effort, all of this money, all of this engineering genius, all of this was built for one single purpose: to answer one question that had sat completely unanswered in physics for over 100 years. What actually gave matter its mass? Why does an electron have weight, but a photon, a particle of pure light, has absolutely none? What force, what particle, what mechanism reached into the early universe and decided what would be heavy and what would not? Back in 1964, a British physicist named Peter Higgs sat down and mathematically predicted the existence of a particle that could answer all of these questions. A particle that interacts with matter and gives it mass. He called it the Higgs Boson. For 48 consecutive years after that prediction, generation after generation of physicists searched for this particle using every tool and technology available to them, and found nothing. Then on July 4th, 2012, the scientists at CERN gathered in a packed auditorium and announced to the world that they had finally, after nearly 5 decades, detected the unmistakable signature of the Higgs boson in their collision data. Peter Higgs himself was sitting in that auditorium. He was 83 years old. He had spent his entire adult life waiting for this moment, not knowing if he would ever live to see it confirmed. When the announcement was made, he cried. But now let us go back to the fear, because this is the part of the story that most people remember. The concern was specific, that the extreme energy of these particle collisions could spontaneously generate a microscopic black hole directly beneath the surface of the Earth. And that this black hole, once created, would not simply disappear. It would begin pulling in surrounding matter, growing larger and more powerful with every passing moment until it had consumed the entire planet from the inside out. This fear was serious enough that actual legal cases were filed in actual courts of law in both Europe and the United States, with plaintiffs formally demanding that the experiment be halted before it could begin. The response from the scientific community was measured, clear, and backed by solid mathematics. The universe itself has been producing particle collisions far more energetic than anything the LHC could ever generate, and it does so constantly, every single day, all around us. These are called cosmic rays, high-energy particles traveling at tremendous speeds from the deepest regions of space. And they have been bombarding the Earth, the Moon, and every other body in our solar system with energies billions of times greater than the LHC for billions of years. The Earth has been absorbing these cosmic collisions continuously for 4.5 billion years and remains completely intact and perfectly stable. If collisions of this kind were capable of creating dangerous black holes, our planet would have ceased to exist long before the first human being ever walked on it. Now, here is something that almost never gets mentioned when people talk about CERN. The internet, the actual World Wide Web that you are using right now to watch this video, was invented inside CERN in 1989. Not inspired by CERN, not funded by CERN. Literally invented there. A scientist named Tim Berners-Lee was working at CERN and needed a reliable way to share enormous amounts of research data between scientific institutions spread across different countries. His solution to that problem became the foundation of the entire modern internet. And proton therapy, the precise cancer treatment that uses accelerated proton beams to destroy tumors from within while leaving surrounding healthy tissue completely unharmed, is a direct product of the particle accelerator technology pioneered at facilities exactly like CERN. It is saving real lives in real hospitals right now. CERN is currently in the advanced planning stages for its next machine, the Future Circular Collider, known as the FCC. It will be 91 kilometers in circumference and will operate at energy levels 7 times greater than the LHC has ever achieved. The primary scientific targets of the FCC are dark matter and dark energy, the two mysterious components that together make up roughly 95% of everything that exists in the universe, yet which we have never directly observed or been able to explain in any satisfying way. Every technology that defines modern life was terrifying to someone when it first appeared. The fear is understandable, but when that fear is allowed to stop the work, we lose the discoveries that change everything. The science that once made people write their wills is the same science that is saving lives today.